Welcome to Hydrology. I'm Dr. Marty Matlock. I'm the instructor for this course. I'm an EcoHydrologist, which means I have a Ph.D. in biosystems engineering with a background in ecology and hydrology. My professional engineering license in Texas is in hydrology. It's my area of expertise. I'm a board-certified environmental engineer in sustainability with a focus on water resources. Today we're going to introduce hydrology from the context of water, food, and civilization. In essence, everything is connected. And that connection extends from our ecological domain, the biosphere, to our social domain, cities, countries, civilization at large, and our economic domain, the transactions we engage in as we extract resources from the biosphere and transfer those resources through the social domain. And our big challenge is that everything is changing. Everything on this planet is changing at a rate faster than anyone or any civilization has ever experienced. Understanding these changes and their impacts on our immediate and more distant futures is very complex. It falls into the area of unknown unknowns. But as engineers, we have to design for that future. So our challenge, especially as we deal with hydrology, is to understand how these changes impact our future and how we can maintain our allegiance to the engineering ethic as we practice the engineering discipline of hydrology. Because we're all in this together. There are 7.35 billion souls on the planet today. We expect by 2100 that we will have between 9.5 billion and 10 billion people sharing this earth with us. Our challenge is to maintain and, in fact, expand prosperity to all of humanity while we are also preserving other life on this planet. Hydrology is the science or study, that is the logy, from the Latin logia, of water, hydro, from the Greek hudor, not to be confused with Hodor, from those of you who happen to be former Game of Thrones fans. Modern hydrology does not study all of the properties of water, however, because, frankly, that's essentially the study of Earth and humanity. Modern hydrology studies the distribution of water on the surface of the Earth and its movements over and beneath the surface and through the atmosphere. Engineering hydrology is the study of hydrologic characteristics of a watershed or a drainage system, required to solve a problem with design, operation, and management of flood control works, irrigation systems, water supply projects, runoff drainage, erosion controls, highway culverts, any of the hydrologic things that we design. Understanding the processes in non-human dominated watersheds and then managing human dominated watersheds for complex, multifaceted outcomes. The study includes frequency analysis of hydrologic events, depth area duration analysis, estimation of evapotranspiration, hydrograph analysis, stream flow routing, rain runoff relationships, stream flow simulation, estimation of soil erosion and stream sedimentation, risk analysis, and many others. Now, hydrology is not new. In fact, the Romans, even the Greeks, all of human civilization, by definition, has managed water because we are a hydraulic species. We have always lived near water supplies. We can't live without it. It's our first need as a physiological species. It is also one of our first needs as a civilization. There's a whole bunch of categorizations of the study of water under the logies. Potamology, which we really don't use anymore, is the study of streams and flowing river or water and flowing channels. We generally just lump that into limnology these days, which is the study of reservoirs and lakes. But potamology and limnology have pretty much converged. Cryology, the study of ice. Oceanography, you all know, due to Jacques Cousteau and many other famous oceanographers. Glaciology. Hydrometeorology, hydrogeology, the study of water movement through the earth, and hydrometry, the measurement of all those things. Those are just the categories of studies of water based upon the body of water. And then there's a study of land use conditions, rangeland hydrology, for example, agriculture, forest, urban, wetland, desert, urban hydrology. It's not on the list, but it is on the list, but it is becoming a major area and probably is the area of practice that you will be most engaged in. Interdisciplinary approaches, geomorphology, how water shapes the land, paleohydrology, how water has shaped the land in the past, engineering hydrology, which is what we're engaged in this course, watershed management, which is related to engineering hydrology, hydrobiology, the relationship of water and living things, and ecohydrology, the relationship of water and environment and living things all combined. EcoHydrology is a specialization that will inform this class in engineering hydrology, because we are not just studying the movement of water on the land, but the way the movement of water on the land impacts things. It's a combination of engineering hydrology and limnology. Now, this is an engineering hydrology course, but we will tackle some of the limnological issues associated with engineering hydrology. So this is engineering hydrology with an ecohydrology focus. Limnology is the study of life and phenomena of rivers, lakes, and ponds, as we just discussed, and functional relationships and productivity of freshwater communities as related to their physical, chemical, and biotic environment. Why do we care about this? Because things that live in the water affect us, whether they are pathogens or whether they are fish that we consume or whether they are ecosystem characteristics that drive the reduction, like algae, that drive the reduction of phosphorus down in water quality as water moves from headwaters down into the ocean. It is all about us, ultimately. So as we explore the relationships of water across the human spectrum of experiences, we will also use the Sustainable Development Goals to frame these discussions. The Sustainable Development Goals, as you can see from the hyperlink, are from the United Nations Development Program as part of the United Nations Environmental Program to identify the things that matter most to us as a species. There are 17 Sustainable Development Goals. They're fairly self-evident: no poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation, and infrastructure, reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice, and strong institutions, and partnerships to achieve these goals. There's not a one of these 17 goals that doesn't touch water directly. For example, peace, justice, and strong institutions. These are issues that we've had to address dramatically over the last several months and years. Let's just take a look at this issue as a sustainable development goal. Over 70% of victims of trafficking over the last decade are women and girls, largely in sex trades. Almost 1 in 3 people in the world are held in detention without being tried or sentenced for a crime in 2015. 18% of firms worldwide reported receiving one bribery payment request. What does this have to do with water? Water supply for people is a civil infrastructure issue. We will touch upon this later, but just I want to put this number in your head. 3,000 children will die today due to preventable waterborne disease. 3,000 children will die tomorrow due to preventable waterborne disease. The reason we do not solve this problem isn't because it's technologically hard. You're engineering students. You understand it's easy. A 55-gallon steel drum filled with sand, a little PVC pipe, and a gallon of bleach, and we can make water safe to drink for a whole community. That's not hard. What's hard is building the civil infrastructure to ensure that that water supply is protected and that that water treatment system is maintained. That civil infrastructure requires peace, justice, and strong institutions. just like our criminal justice system in the United States has deep biases and bigotries, so does our water availability system. I just want to touch on this because it's important that we understand that injustice runs deep and it transcends, it intersects just about every facet of the human experience. Between 1980 and 2015, the number of people incarcerated in America increased from 500,000 to 2.2 million. African Americans, which are a relatively small portion of the population in the United States, about 18%, generally 16 to 18%, are incarcerated at more than 5 times the rate of whites. Not because they commit more crimes. To be clear, it's not because they commit more crimes. Crimes committed in the United States are pretty much agnostic to ethnicity or race. They pretty much follow the proportion of the population. Yet our imprisonment is disproportionate. African Americans, women are twice as likely to be imprisoned than white women, not because they commit more crimes, but because our justice system has bias. Though African Americans and Hispanics make up 32% collectively of the U.S. population, they were more than half of all incarcerated people in 2050. Spending in prisons and jails has increased at triple the rate of spending of pre-K through 12 education in the last 30 years. Think about that as an issue of priorities. And it gets even worse. As of 2002, about 29% of people in local jails, not prisons, local jails are where you go when you're waiting to stand trial, were unconvicted. They were locked up while they were waiting trial. In 2018, that number doubled, which means that about a third of the 720,000 people in jails on a given day have not been convicted of anything. They've been arrested and accused, but not convicted. 69% of these detainees were people of color, 43% black, almost 20% Hispanic. Why? Because they can't pay for the bail. They can't make bond. They can't bail themselves out. So they're sitting in jail because they're poor. Local governments make money off of pre-incarcerated people, and for-profit prisons make a lot of money off of incarcerated people. Where there's money to be made, there's bias, bigotry, and corruption. Now let's talk about why I'm describing this to you. Because I want to make it clear to you that there's a connection between how you learn and what you feel. It's about how memory works. And so throughout this class, I'm going to try to make you feel things about hydrology and not just give you information and data, because that's one of the ways to learn. There's a direct and strong correlation between memory and emotion. Emotion improves memory for just and basic level visual information, just as sort of the framing. For both time and space, the type of memory matters. Events that involve arousal produced by empathy rather than shocking stimulus really does improve your emotion with no memory narrowing. When you're shocked by something, you focus on that one thing. When you're empathetic, you see the whole picture. And so those are cognitive processes that we will use in our pedagogy. I'm not going to try to shock you, but I'm going to try to make you understand these facts as truths that have significance. Because here's our fundamental reality. We have to balance these things we care about. We have tensions between things we care about, and we have to make choices. And as engineers, we have to design things that realize those choices. That's when society says this matters, we need to be competent to design solutions that take into account and make clear the choices that we're making. If we look at clean water and sanitation as sort of the a central focus area of concern, and then decent work and economic growth and zero hunger as sort of our primary goals for sustainability and hydrology, we can see that all the other goals connect to them: poverty, quality education, good health and well-being, climate action, life on land and life below water directly touch those sort of 3 central goals. And then gender equality, affordable energy, responsible consumption, sustainable cities, industry innovation, partnerships, reduced inequalities, and peace, justice, and strong institutions all connect to these goals. Everything is connected. Our challenge is that everything is changing. So if we look at climate action, we see those changes in action. Those changes are affecting how we live and where we live. We're looking at thermal properties of the Earth on an average annual basis in degrees Fahrenheit over the last 40 years. Notice where and when things heat up. The northern Arctic, in particular, is getting the brunt of global climate change thermal regime alteration. But also look at the Middle East, look at Africa. Now we know the tundra across Canada and Alaska is thawing, and we know that Siberian tundra is changing. We don't know the impacts those are going to have on greenhouse gas emissions because there's a lot of methane tied up in that tundra, frozen. And as it thaws, that methane, that carbon will convert to methane, and that leads to concerns about nonlinear climate change impacts, runaway climate change. Because prosperity is our common goal. This is not just about keeping the world the way it is. We need to make things better. We need to change because too many people do not have enough to live prosperously. Maya Angelou said there's a world of difference between truth and facts. Facts can often obscure the truth. Truth is a value framing. We have values, all of us do, individually, as families, as communities, as civilizations. We need to understand the facts that we observe in the context of those truths. Right now, as I indicated earlier, we're at about 7.35 billion people on the planet. Now, in 1950, half of those folks, half of the roughly 2.25 to 2.5 billion people on the planet were starving. We were in the ashes of the Second World War. We were struggling to put back supply chains, to build economies back in Europe and around the world. The Green Revolution, led by Norman Borlaug, pictured here, one of my mentors and friends, set about to free humanity from the tyranny of hunger, not just to feed the world or grow more crops, but free humanity from the tyranny of hunger so humanity could then aspire to higher things, and also to save land for other things. Norman Borlaug told me back in 1984 that he'd watched his life's work devoured by the population monster. Fortunately, he lived long enough through about 2004 to see his projections or his concerns that the population monster had devoured his work proven to be untrue. Yes, while projections of current fertility rates put us at about 12 billion by 2050, which is only 30 years from now, median estimates really are dropping this back down to about 9 to 9.5 billion. However, the uncertainty about this could drop us below 8 billion, which is just 750 million more than we currently have on the planet today. What we do in the next 10 years will determine where this curve goes. Borlaug pointed out that prosperity, human well-being, leads to lower fertility rates. He also pointed out that when technology and cultures collide, technology always prevails and cultures always change. Growth in population is occurring in less developed regions. If you're in the business of packaging things up and selling it to people and you want expanded markets, those markets aren't going to come from more developed regions. It's going to be important that you expand your markets to areas where populations are growing. That means less developed economies. So this is where we currently live. This is where the people are. If you're in the business of serving people, as a consumer packaged good company or as an engineer solving problems, you need to know where people are. This is where people will be by 2050. And you can see there's a significant shift to Africa, to India, and to China. That's where the most population growth is going to occur over the next 30 years. We're living in the period of the Great Acceleration, where we're seeing greenhouse gas concentrations in the atmosphere accelerating at dramatic rates. Atmospheric nitrous oxide concentrations are accelerating, as well as methane concentrations. The climate impacts mean that we're seeing average temperatures increase, and from our perspective, great floods, frequency and intensity of extreme events are increasing as well. Ocean impacts are changing. Ocean ecosystems, coastal zone structures, biogeochemistry are changing. And terrestrial impacts are changing. The drivers of those change are pretty self-evident. Population increases, increasing in prosperity of humanity, real GDP, as well as direct investment in foreign systems. So economic growth is a driver. We are changing water resources and agriculture to feed those people, to feed us. We're damming rivers. Water use is increasing. Water appropriation by humans, of course, is increasing with our population. And we're using more fertilizers because you can't grow more crops with the same amount of nitrogen and phosphorus. Crops are fundamentally carbon, nitrogen, phosphorus, and about 16 other atoms or minerals with water. Our prosperity is increasing. Look at our urban population, as we will see as we discuss urban hydrology. Paper consumption, though it's actually tapering off as we move to a paperless society. The number of McDonald's restaurants since 1950. Finally, motor vehicle use, global telecommunication, international tourism, notwithstanding our current pandemic, are dramatically increasing. As we talk about hydrology and think about our impact on the world, we have to consider this in terms of sustainability. The Brundtland Commission in 1987 defined sustainability fairly clearly. Sustainability is the ability of humanity to make developmental changes to meet our own needs without compromising the ability of future generations to meet their needs. So that means we have limits. We live in a world of limits, and we have to make choices about how we use resources that are limited and how we allocate those resources. Water is one of those resources. Hydrology is actually part of the process by which we use to manage water resources. Finally, recognized in '87 was this fundamental truth 30 years ago, that a world in which poverty is endemic will always be prone to ecological and other catastrophes. Poverty is our first challenge. Let's talk about our human species from a big perspective, from a sort of an anthropological perspective. From over 1 million years ago till about 1000 AD, we were ambling along as a species. We had a couple of really big constraints, and there was a point at which we may not have made it. We were constricted by global events as a species, but then we sort of caught on, and we were doing fine. We have this little dip called the Black Death, the Great Plague of about the Dark Ages, the 1200 to about 1500, and then we really took off as a species. This is a classic exponential growth curve. So in the time of our parents and grandparents, we have seen changes we have never experienced before as a species. The rate of expansion of our species population has driven all sorts of social, economic changes. My grandfather was born in 1917 in the era of monarchs, czars, kings, and emperors. He experienced a global catastrophe called World Wars I and II with a little halftime interlude that resulted in a dramatic transformation of the way we govern ourselves, the era of democracy. We're in that era now. We don't know how this is going to turn out. This is your era, the 21st century. How will the 21st century turn out for democracy, for self-determination, for the rights of humans, which we began dabbling with in a real serious way about 1776? We do not know. Now we see this significant drop-off in population at 2100. This is a prediction not driven by some catastrophic event or human failing. This is actually a measure of success. This is when population increases, or when the population growth curve reaches population zero. This is when our fertility rates drop below our replacement rates. That is about 2.3 children per couple. In some places 2.18, depending on mortality rates and other issues. So this is when suddenly everything changes. If we can reach this point and maintain the resources and civil society that we have been able to achieve in the last 1,000 years, it is entirely possible we can write a new future for humanity that is not scarcity-based, because we will have fewer people vying for the same resources. And that could create an entirely new level of prosperity unimaginable in human history. Borlaug always said, like many, in order to know where you're going, you have to know where we came from and how we got here. So our population growth, this red line is our annual growth rate. Our population growth rate actually, as we look at global population increases, actually peaked about the time, about 1970, at 2.1%. And the rate of population growth is coming down. When it hits about 0.1%, we're going to hit about neutral population, 2100. Now, that's 11.2 billion, could be 10 billion. We don't know. There's uncertainty about where this goes. But according to median fertility projections, it could be 11 billion. It could be 10 billion. Depends on how fast this rate declines. Again, in 1950, 30% of humanity was chronically malnourished, half were food insecure. China was starving. It led to a major revolution, the Maoist revolution in China. It was a tragedy of human proportions. Today, only 11% of humanity is hungry. China has been one of the greatest success stories in human prosperity ever. Not without challenges, not without difficulty, but a major success. In 1950, child mortality, that is, death before 5 years of life, was greater than 22%. More than 1 in 5 children died before they reached reached 5 years of age. Today, it's less than 4%, 1 in 25. Still too many. I grew up in Oklahoma. My grandparents survived the Dust Bowl, an ecological catastrophe of dramatic proportions and impact on the United States. The Great Depression and the Dust Bowl are synonymous. It was the largest man-made ecological catastrophe or failure, ecosystem failure in modern history. It resulted in displacement of millions of people. It resulted in deaths. It resulted in loss of production. We understand the value of prosperity from the land. It creates opportunity for people to improve their lives and the lives of their children. It also creates an opportunity for people who do not have land to prosper through land-based production of fruits and vegetables in particular. In 1950, more than 44% of the world was illiterate. Today, 86% of us can read or write. Read and write. That is dramatic. Literacy is the first step out of poverty. So how did we get here? Sweat, a lot of hard work by a lot of people collaborating across disciplines, and science, better understanding of the challenges we face and the solutions for those challenges together. Sweat and science, that's what you're in for the next 5 weeks. So where are we going? Our global population distribution, as we discussed earlier, is not uniform across the planet. The United States has a relatively low population density, especially given our land mass and natural resources. Average years of female schooling from 2010 and total fertility rates are directly connected. Education and fertility rates are directly connected. If we look at number of girls in school, the lighter blue representing fewer girls in school, and we look at fertility, births per women, we see a geospatial correlation. And that correlation is causal. You also see, because this is where the fertility rates are highest, this is where the population growth is also the highest. Total fertility rates by development, including UN projections through 2100, show that least developed countries with medium fertility variance are coming down. More developed regions are obviously starting lower and coming down lower. So fertility rates, the number of children a woman has in her lifetime. This medium fertility variant for the world, this is the world average. If we look at the highest rate, it's least developed, then less developed countries. So if we want to move this curve down to this range, we have to start with where the problems are: least developed countries and less developed countries. These locations. And the way we do that is we educate women. Because zero population growth is right about this line. And we need to move these lines, all three of these lines, to below this line. The global north, typically what we call the developed economies, hit this in the 1970s. If we look at the total fertility rate of women related to the enrollment in secondary school, we see that the more girls that are enrolled in secondary school, the lower the fertility rates. Education has been called the greatest birth control in human history. Educated women are empowered women who can make decisions about their destinies. Finally, education and fertility are connected to poverty, and we've already discussed that poverty is the biggest driver of human suffering. If we want to reduce poverty, we need to educate women to reduce fertility rates. Poor women have more children. Poor people have more children. We did that in our country because the family unit is our economic unit of prosperity. The more children we have, the more probable that some of those children will live to adulthood, and the more resources we can bring into that family unit, that economic unit. That is especially in a subsistence culture. If we move to more prosperous productivity, where we have civil society infrastructure and equitable wages, you don't need that many children to produce adequate resources for some self-control over your destiny economically. Poverty is the most insidious driver of unsustainable decisions. Poverty is caused by a myriad of factors. Disruption of ecological, social, and political systems is the most common cause of emergence of poverty. Think about civil wars, famines, droughts. They're all connected. Equitable distribution of resources is the principal cause of persistent poverty. That is the poverty that is always there in some societies. And that's just because of inequitable distribution of resources. That's an issue of fairness. Inequity will not persist in civil society. Remember, we have our ecological systems and social systems and economic systems nested. And when ecological systems fail, social systems and economic systems fail. When social systems fail, economic systems and ecological systems fail. When economic systems fail, social systems and ecological systems fail. They are all connected. Life is hard if you are poor. Your resilience, the ability to persist or recover after a disruptive event, is directly tied to your economic well-being. The death of a husband can result in the loss of main income sources. Riverbank erosion can result in the loss of a home. Old age can reduce your ability to work and collect drinking water, resulting in deterioration of health due to drinking higher saline water or contaminated water. Higher levels of salinity in your water based upon seawater intrusion and ocean level rises can deteriorate health. A cyclone can result in loss of home, income, loss of livestock, which can in many cases is the only thing women can own in many parts of the world. And so loss of livestock means a loss of their wealth, which means increased levels of food insecurity over time. These are all the ways that environmental impacts affect poverty. Your resilience is the ability to bounce back after you get hit. So the ability to come back, you get hit, you drop down, your ability to bounce back and how far back up you bounce is a measure of resiliency, and the time it takes is a measure of resiliency. There are many components of vulnerability that drive resiliency. Initial well-being, nutrition, physical and mental health, class position, gender, ethnicity, age, livelihood, income opportunities, qualifications, assets and savings, plus everything above, plus the shifts in power relations and the effect on livelihood after hazard impacts. Self-protection, building quality, hazard protection, location of home and livelihood. The socioeconomic drivers are technical and ability and knowledge and availability of protective measures, plus the types of protection, cost, feasibility, return period, duration, intensity, and magnitude of extreme events. This is where hydrology comes in. Societal protection, building regulations, technical interventions by higher levels of government, for example, during a pandemic. Levels of scientific knowledge, characteristics of technical practices within communities, that is knowledge elites, power elites, quality and robustness of insurance systems, type of science and engineering used by states and dominant groups affect whether society is protected. And finally, social capital, probably the biggest driver of resiliency of communities. Social cohesion. Do you help each other? Do you know your neighbors? Do you work together? Rivalries between communities. Number and strength of potentially conflicting groups. How state power is utilized. Capacity for civil society to develop and enable positive networks and interaction. What happens when your community, your city, your state, your island is hit by a catastrophic hurricane, which is largely wind and flood damage? Is the state in a position to support your recovery or not? The cascading effect really is the phenomena that drives major catastrophes. So you have a disaster impact that results in economic, humanitarian, or ecological impacts, which result in cascading loss of capital stock, business interruptions, loss of GDP. You could plug into this disaster impact a pandemic with the associated shutdown of businesses to protect human lives with the resulting impacts of the economy. If we look at economic losses from natural catastrophes in the 20th century, from 1950 to 2000, you don't have to be a genius to see that they're increasing. Economic losses are increasing. Insured losses are all over the board because many of these economic losses are in uninsured areas. But insured losses are going up too if you look at the trend line. This is why the insurance companies are all about climate change adaptation and making sure we stop pumping more climate active greenhouse gases into the atmosphere, because they're losing money. but we're all losing money. We're all losing resources. And this is partially because of increased intensity and frequency of extreme events. And it's also partially because we built a whole lot more stuff on the coast where things happen, or in the river bottoms where things happen. So we're more vulnerable because we built more, because there's more of us, and because the things that impact what we built are increasing. Now, poverty is the most insidious driver of unsustainable decisions. Remember, I told you that you need to feel something to understand and to remember it. Kevin Carter took a picture at a child aid station in Sudan during a drought in 1993 of a young girl, who was at the aid station but effectively left behind. He took this photograph and he won a Pulitzer Prize for it in 1993. A year later, he committed suicide. Now, Kevin picked this girl up and carried her to the aid station. She didn't survive. She was too far gone, too emaciated from the impacts of starvation. But he was haunted by this. What does it take for humanity to act? Humanity did not act in an aggressive manner to protect the people of the Sudan in 1993, any more than the people of Lebanon, Syria, most of the Middle East during their major droughts of 2001 through 2006. Drought resulted in famine, resulted in refugees, resulted in genocide, resulted in civil war, resulted in famine. This is the human condition. As hydrologists, we understand some of these causal factors. We can predict them and we can mitigate them. Drought is just water scarcity. We can mitigate water scarcity. Wendellberry says it may be that when we no longer know what to do, we've come to our real work, and we will no longer know which way to go, we've begun our real journey. The mind that is not baffled is not employed. The impeded stream is the one that sings. So here's our real work. This is a 3-semester credit hour class in hydrology, the study of water flowing across the land, its impacts and designs. This class will be taught in the second semester. It'll be taught from June 29th till July 29th or July 30th, 5 weeks, using distance technologies. This is an introductory course in hydrology and will prepare students for advanced studies in engineering, hydrology, and design. Through this course, you'll understand city, state, and federal regs related to water resources. You'll be able to delineate a watershed, its physical and hydrologic characteristics, analyze a site within a watershed to determine those characteristics based on existing and future land uses, simulate rainfall events and designate return periods using analysis of data records. Using available data, simulate rainfall and runoff for a site for a discrete event, and for design return periods using the rational method, SCS method, and the USGA regression equations. Analyze and simulate stream flow characteristics impacting design. Apply the unit hydrograph method to determine stream flow during pre and post land use change scenarios. Analyze and simulate water quality from land use. Analyze and design water detention and routing systems to meet stormwater regulations, control regulations, among other things. This is a 3-semester credit hour course. You'll have 9 hours of recorded lecture per week to give you 45 hours of lecture. About 18 hours of outside class effort per week. That means this is 27 hours per week for this class. This is what it takes to take a 3-semester credit hour class in 5 weeks. Class assignments will include post-lecture quizzes, questions related to the lecture material, assignment-based calculations, and designs from cumulative assignments. Grades are composed of cumulative points from the assignments. This goes fast. Do not fall behind. You have the syllabus. It's in Blackboard. I circulated it to the class beforehand. In 5 weeks, we'll cover water, issues as hydrology as a science, precipitation and evaporation, storage and runoff, stream flow analysis and modeling, and water quality. We will move through each of these weeks systematically. We will have 2 lectures on average for each topic, A through E, in each week. And then we will have 5 assignments each week, each worth 200 points, for a total of 5,000 points for assignments. We'll also have a quiz after every lecture worth 100 points. That's 45 lectures, 45 quizzes, 4,500 points. Class attendance and participation really is about your engagement in our online synchronous and asynchronous discussions. I need to see that you're here and engaged. These are easy to earn. Just show up. Show up when you're invited. For asynchronous activities where you're just supposed to post comments or discussions or your opinions, do so. And that'll give us a total of 10,000 points. That's a lot of points. Now you got to earn 9,000 of those to make an A, 8,000 to make a B, 7,000 to make a C. Anything less than that, you might as well not show up. Thank you for your attention. We've concluded this lecture. Each of these lectures will be posted on Blackboard, and you will have both the video lecture with audio as well as the PowerPoints to refer to. And there will be associated readings for each of the topics. I'm available. If you have any questions, you can reach me at my email, which is on the syllabus. You all already have my email. You can also text or call me if you need. There are 13 students in this class so far. We should be able to move through this class with relative competency and without much disruption. It's going to be fast, though, so please, please, please stay engaged. Thank you very much. I look forward to working with you over the next 5 weeks.